Hello, dear students. This is the question from mathematics paper, mechanics mathematics paper, paper 4. And this is from 2025 Feb March paper, question number 6. So you can see a block of mass 12 kg is placed on a rough plane. So this plane, we can say it's a rough plane which has a friction, it's not a smooth plane, and it is inclined at an angle alpha to the horizontal, where alpha tan inverse is equals to tan inverse of zero point 0.5. The force x is acting upwards like that, you can see there, is applied to the block directly up the plane, and you can refer the diagram. The coefficient of friction mu, okay, between the block and the plane is mu, and the value for a, it is 0.15. The x force which is given up the plane is 20. So we have to calculate the time taken that it takes for the block to move 2 meters down the plane from rest. Okay, so just I have copied the um, diagram alone, okay, for to draw a free body diagram I have copied. So let's do this. So for example, uh, if you see this one, it is 12 kg block. One, the weight will be acting towards down, right? So that is, let's take 10 for gravity, 120 newtons. So if I resolve the components into two, up the plane, sorry, down the plane and perpendicular to the plane, I'll be getting, this will be my 120 sine alpha, and this will be 120 cos alpha. So first we'll find what is alpha. So alpha is simply tan inverse of zero point 0.5 they have given in the question. So if I use my calculator to do that, tan inverse of zero point 0.5, I am getting a value of 26.56. So let's copy that here. So alpha is 26.56 degrees. Okay, yes. Now the block is going down. Okay, it is accelerating towards down like that. It's accelerating towards down like that. Okay, the acceleration is towards down. So the friction will be acting in opposite direction. Okay, friction will be acting in this way. Friction will be acting in this way. So I am assuming Fr for friction. So Fr is friction for us. Fr is friction. Okay. Now we can create the equations. So F net is equals to ma. We know from the Newton's third law. So we have to find the acceleration, that will be equal to F net divided by m. So F net is 120 sine alpha. Okay, 120 sine alpha value we have got, that is 26.56, minus x is 20 they have given in the question, minus 20, minus Fr, that is mu into n. Okay, divided by the mass, which is 12 kg. So find Fr first. Okay, then I can place it there. Mu n, mu they have given us 0.15, n is just the reaction force is equivalent to 120 cos alpha, right? Okay, so now I can write that here. So this will be n, that is 120 cos 26.56 degrees. So if you multiply, if r is coming as, I'm using the calculator, cos 26.56, 16, I'm getting 16 for that. Okay, so instead of mu n, I can write 16 here. Okay, and I can write 16 here. So if you calculate that, the acceleration, Okay, the acceleration is coming as, let's do that, 120 sine 26.56 minus 20 minus 16, which is 36, divided by 12. So it's 1.47 meter per second square. That is the acceleration. But we have to find what is the time taken for the block to come down 2 meters below the plane, down the plane from the rest. So from here to here, let's assume that this is 2 meters, and we have constant acceleration 1.47 meter per second square, meter per second square. So now we can use equations of motion here. S is equals to ut plus half at square, and since the block starts from rest, okay, we can say u is 0, so this term will become 0. So s will be equal to half at square. Okay, so 2 meters is s, okay, they have given in the question. Half a is 1.47 and into t square. So if you calculate for t, it will be 2 into 2 divided by 1.47 whole root. So if we calculate that, so 4 divided by 1.47 the whole root, I'm getting time as 1.64 seconds. 1.64 seconds. So this will be our time for the block to reach 2 meters below the down the plane. Now next question, if you see the same question, but it's a B part of the question. Okay, B part of the question. Again, I have taken one picture. Yeah, so it is given that instead mu is not equal to 0.15 when x is equals to 10. The block is on the point of moving down the plane, just it wants to move down. We can consider that it is at rest or it is in equilibrium. So at this moment I can take the x value as 10. Okay, and here again it will be 120 sine alpha, and it is just going down the plane, so friction will be in that way. Okay, now it is in equilibrium, so I can find the friction with the help of this. So 120, alpha is not changing, sine of 26 point, sorry, what was the alpha, let's 26.56. Okay, 26.56, that is equal to 10 plus fr. So fr will be equal to this minus that. So if I calculate that, 120 sine of 26.56 minus 10, I'll be getting fr. Fr is 43.65 newtons. Okay, so this is important. Now they're asking find the value of mu and x for which the block is on the point of moving up the plane. Just it wants to go up the plane, okay. In that case, the fr will be acting in opposite direction. And before that, we can find the mu value, because fr, that is frictional force, is equals to mu times n. So mu will be equal to fr divided by n. So fr is 43.65, n is 120 cos alpha. So alpha value is 26.56. I can place it there. Alpha value is 26.56. So if I calculate it, I'm getting as 0.40. That is the mu value which we are getting. Now since it goes up the plane, okay, the fr will be in opposite direction. The fr I can just draw in the opposite direction, fr, and we don't know what is the x for that up the plane. We have to find x for that. Okay, so x will be simply 120 sine alpha plus fr. So let me write that, x is equal to 120 sine alpha, which is 53.65, plus fr, which is 43.65. So we'll be getting around 97. Let me calculate it. We'll be getting around 97.3 newtons. So that will be the answer for x. Hope this explanation helps you to understand this question. Thank you, students.